Today we'll start a new chapter, that is chapter number 4, and the name of the chapter is quadratic equations. So in the previous classes we have studied about the different type of equations. You studied about the linear equation in one variable, x plus 3 equal to 5. This is a linear equation in one variable. And even in class 9 and even in class 10 you studied about the linear equation in two variable. You have studied this kind of equation, but today we're going to introduce a new type of equation, that is quadratic equation. In case of the quadratic equation, what happened? The degree of the equation should be 2. That means the highest power of the variable should be 2. I'll give you an example here. X square plus twice x plus 1 equal to 0. This is an equation. But when we look at the power of the variable, I have here power 2 and I have here power 1. So the biggest power, that means the degree, is 2. So this kind of equation is actually what we call quadratic equation. And I'll give you some more example. Thrice x square plus 5x plus, let me say here, twice x equal to 0. This is also a quadratic equation. So let me repeat. In case of the quadratic equation, what happened? The degree of the equation should be 2. That means the highest power of the variable should be 2. And here in chapter 4 we'll study those type of quadratic equations that contain only one type of variable. You'll not find here x, y together. If you get here x, only x. If you get y, there will be only y. So only one type of variable will be present there. Okay, so next I'll tell you general form of quadratic equation. So the general form of quadratic equation is ax square plus bx plus c equal to 0. Okay, before I start this, let me tell you, ax square plus bx plus c. You have found this even in class 10 in the previous chapter and even in class 9 as well. This is what we call general form of quadratic polynomial. The same thing here. When it comes to equation, we will find definitely one equality sign here. That means you're equal to. What are these a, b and c? Let me tell you. These a, b and c, these are all real number. These are all real numbers. A also should be real number, b also should be real number, and c also should be real number. And one of the most important conditions is this a should not be 0. And now why I'm telling this? Why the value of a should not be 0? There is a meaning behind. Okay. If a is 0, what happened? If a is 0. If a is 0, then what happened? This part becomes 0. So we have now 0 plus bx plus c equal to 0. That means bx plus c equal to 0. But finally, what do you get? When the value of a is 0, it is no more a quadratic equation. It becomes a linear equation. Therefore, this value of a should not be 0. Okay. So now my question is, why do we call this form, this ax squared plus bx plus c, as the general form of quadratic equation? Because every quadratic equation in one variable can be expressed in the form of ax squared plus bx plus c equal to 0. Okay, I'll give you the example. Let me write here once again, ax squared plus bx plus c equal to 0. Let me write here one quadratic equation. Let me say 7x squared plus 5x plus 1 equal to 0. Even this equation, now this is in the form of ax squared plus bx plus c, because x squared we have. Now here a means 7, here xx, b means 5, and c means 1. And let me write in another form, let me say x square minus 1 equal to 0. This is a quadratic equation. Why? Because the highest power of x, the highest power of the variable is 2. Degree is 2. Therefore, it is a quadratic equation. But now the question is, can we express this in the form of ax square plus bx plus c equal to 0? The answer is yes. How can we? I can express this as x square plus 0x minus 1 equal to 0. 0x is not there before, but 0 into x you'll get 0. So plus 0 means it doesn't affect anything. So now this x square plus 0x minus 1 equal to 0. This is in the form of ax square plus bx plus c equal to 0. Here a means 1, b means 0, and c means minus 1. Okay, so after this, let me come to the solution of the equation, solution of the quadratic equation. So we'll study afterward how to find the solution, but let me tell you the meaning. What is meant by solution? Let me write here one equation. Here x square plus 5x plus 6 equal to 0. This is a quadratic equation. Here, by taking different values of x, we can check whether left hand side and right hand side are equal or not. Okay, let's see. So first let me take x equal to 1. So left hand side will be how much? 1 square plus 5 into 1 plus 6. Then we have, it will be 1 plus 5 plus 6. So we get here 12. But on the right hand side we have 0. That means it is not equal to what? Right hand side. Like this, I can take different values of x and I can check whether left hand side and right hand side are equal or not. Okay, now let me take here 2. So when x is 2, what happen? This left hand side will be equal to 2 square plus 5 into 2, then here plus 6. Then we have here 4 plus 10 plus 6, then now we get here 20. So like that I can take different values of x. Still it is not equal to right hand side. Okay, so next I can take here minus 2, x minus 2. Okay, let me see. So minus 2 whole square, I'm talking about left hand side, minus 2 whole square plus here 5 into minus 2 plus 6. Then we have here 4, we have here minus 10, we have here 6, and then I'm getting here 10 minus 10, so I'm getting here 0. So what happened here? When x is minus 2, left hand side and right hand side are equal. Okay, so let me take another number, another value of x. Now let me take here minus 3. When x is what? Minus 3. So left hand side will be how much? Minus 3 whole square plus 5 into minus 3, then here plus 6. So now it's 9 minus 15 plus 6. So now 15 minus 15, we get here 0, then right hand side. So what happened here? When I take the value of x as minus 2, left hand side and right hand side are equal. When I take here x equal to minus 3, left hand side and right hand side are equal. That means these minus 2 and minus 3 are the solutions of this equation. But when I took x equal to 2, x equal to 3, left hand side and right hand side are not equal. Therefore, 2 is not a solution and 3 is not a solution. Okay, so instead of solution, you can even use the word root. Okay, so after this, let me come to this. We can find the roots of the quadratic equation in different ways. First is by drawing the graph. That means we call it graphical method. And second, we have algebraical method. Graphical method means we have to draw the graph and find out the solution, but actually that is not studied in our syllabus. but this algebraical method will study, will solve this. Okay, so in the algebraic method we have some types. We have factorization method. Factorization method means we say normally splitting the middle term. Next we have completing the square. And next we have quadratic formula. Okay, these are the types of algebraical methods that we're going to study in this chapter. So after this, let me introduce one new thing. Let me write here ax square plus bx plus c equal to 0. This is the general form of quadratic equation. Fine. So there is something called discriminant. So what is meant by discriminant? Discriminant is the value which is given by b square minus 4ac. Okay, let me give you the example now. I'll write here x square plus twice x minus 1. Let me say plus 1 equal to 0. Okay, so let me find the discriminant of this quadratic equation. So what is a here? A means 1. What is the value of b? B means 2. And what is the value of c here? C means 1. So discriminant normally we represent with capital D. So d equal to b square minus 4ac. Now what is b here? B means 2. So 2 square minus 4 into a means 1 and c is again 1. So 2 square is 4 minus 4. Then we get here 0. Now the discriminant is how much? This is 0. This is how we find the discriminant. Okay, after this, let me come to the nature of the roots. Nature of the roots. So what is meant by nature of the roots? Okay, let me explain you. So we should know one thing. For any quadratic equation, there should be maximum 2 roots. For a quadratic equation, how many roots should be there? Maximum 2 roots should be there. There should be 2 roots. How many roots? 2 roots, because degree is 2. Degree will give the number of roots. So as for the quadratic equation, degree is 2, therefore it will have 2 roots. Sometimes these roots may be equal or may not be equal. Okay, nature of the roots means how are the roots? Are they real numbers? Are the roots equal or are the roots not equal? That is what we are going to study. Okay, let's see. The first one. For a quadratic equation, if the discriminant is bigger than 0. If the discriminant is bigger than 0, then what happens? The roots are real and distinct. Okay, I'll tell you what is it. The roots are real and distinct. The roots are real means the roots are real numbers. And distinct means the roots are different. Roots are different in a sense. Now, example. I'm solving this equation. Let me say here 6. So what happened? After solving, finally I'm getting here the value of x is minus 2 and x is minus 3. This is a quadratic equation, therefore I should get here 2 values of x. So I'm getting here minus 2 and minus 3. These are the roots. These roots are real number, fine. Distinct means this is minus 2 and this is not minus 2. So one is minus 2 and other is minus 3. That means they are different. That is what we call distinct. Sometimes when you solve, I might get x equal to minus 2 and again x equal to minus 2. In this case, what do we call? Both of them are real numbers, fine. So the roots are real, but equal, because I'm getting minus 2 and again I'm getting minus 2. But here, this thing, why this thing? Because I'm getting different real numbers. Okay, second, if the value of d is 0, then what happened? The roots are real and equal. This is the example of real and equal. These are real numbers, and then I'm getting the same values of x. Next, number 3. If the value of d is less than 0, what happened? The roots are not real. If the value of d is less than 0, that means it may be negative number. It will be negative number. If the value of d is negative number, then what happened? The roots are not real number. They are actually what? Imaginary number. Now we have the first question of exercise 4.1. Check whether the following equations are quadratic or not. Check whether the following are quadratic equations. Okay, we have to check whether this given equation is a quadratic equation or not. Okay, let's see. Solution. X plus 1 whole square equal to 2 times of x minus 3 whole. So this is in the form of a plus b whole square. So a square plus twice ab plus b square. Then we have 2 into x, twice x, then 2 into minus 3, minus 6. So we have x square plus 2x plus 1 equal to twice x minus 6. Now on both sides we have positive twice x, positive twice x. So plus 2x plus 2x. Now I can cancel them. Now what happened? X square plus 1, then minus 6 comes to the right left hand side, it becomes plus 6. Then we have 0 here. Then x square 1 plus 6, we'll get here 7. Okay, so plus 7. So I can write here just 0x equal to 0. Now sorry, this is in the form of which is in the form of ax square plus bx plus c equal to 0. Therefore x plus 1 whole square equal to twice of like x minus 3 whole is a quadratic equation.